Welcome to the fourth part of the final exam review video solutions. We're going to look at the chapter 4 problems, 1 through 4. So in number 1, we're going to use elimination or substitution. You could try to graph them and see how it goes. But I'm going to go ahead and use elimination. So I'm going to multiply this top one by 2. So that becomes now 10x plus 4y equals 2 times 0 is just still 0. And I'm going to keep the other one the same, and that way I can eliminate y. So I'm going to go ahead and then just add those together. So I have 7x, y is gone like I planned it, equals 14. So then x equals 2. And we're going to find both variables, so I'm going to plug that in to either equation. I'm just going to use the top one, 5 times 2. Plus 2y equals 0. So that's 10 plus 2y equals 0. Subtract 10. 2y equals negative 10. Let's divide both sides by 2. So y equals negative 5. And if you want to write your answer as a point on the graph, it would be 2, negative 5. That's their point of intersection. All right, number 2 is one of the long ones. I'm going to go ahead and write that down here so I can give myself more space. Negative x plus 2y minus z 2x. And you can start thinking about, as you're writing it down, which variables would be good to eliminate. You can use any of them, but we need to eliminate the same variable twice on these. That's how you start them off. And so let's look at number 2 now. I've gotten all written it down. Make sure that I got all the negatives there and the right variables. Looks good. Alright, I'm going to go ahead and eliminate x. I like the negative x there at the beginning. So let's first add the first and third equation together to eliminate x. Not to change anything about them because I already have a negative and a positive of the same number. I could just have easily eliminated z, but I just chose to do x. So negative x plus x is gone. 2y minus y is just y. Negative 3z equals negative 1 plus negative 13 is negative 14. All right, that means I need to eliminate y in another way. So I'm going to now use the second equation, or not eliminate y, sorry, eliminate x in a different way. I'm just still going to use the second equation though, so I'm going to do, let's go ahead. So here's our second equation, just rewriting it verbatim, all the same. Let's use the first equation again, but multiply it by 2, so we have a negative 2x at the beginning. Make sure we multiply every single term by 2, so now the y is 4y minus 2z equals negative 2. That's going to be nice. Alright, and add these together. The x's are gone just like we planned it. And I've got 4y plus y is 5y, negative z, and negative 2 plus 2 is 0. So that was really nice. Now from here, I have two equations with two variables, just y and z. So it's going to be a lot like number 1 that we just did. So I can use elimination or substitution. I'm actually going to use substitution since we have this nice 0. So I'm just going to move over the 5y and divide by negative 1. So now I know that z is equal to 5 times whatever y equals. And I can plug that in to the other equation. So I have y still from there, minus 3 times 5y equals negative 14. Now I have just one equation, one variable. Phew! Y minus, just simplifying this side before I finish solving, and negative 14y equals negative 14. So y must be 1. And just like on the first one we did, that's not the end. We need to find both z and x. So let's kind of walk backwards through our solutions. I know that z is equal to 5 times y, so let's plug that in. So z is 5. Now x, we need to go back to the very beginning and pick one of those equations because those ones still had an x in them. I'm just going to choose the third equation. So I have x minus y minus 2z. So I'm going to plug in both my y as 1 and my z is 5. negative 13 still. Scroll down a little bit. So x minus 1 minus 10, or x minus 11 equals negative 13. Add 11 to both sides, and x is negative 2. And just like the last one, if you want to write it at the point, you put your x value, your y value, and then your z. And there's your answer. Okay, let's look at number 3. More words, so exciting. We have a total of 330 tickets. Let's go and write that down. Were sold for this performance. Children's admission tickets were $8 and adults were $13. Tickets receipts for the performance totaled, so this is the money they got, $3,125. I put that next to the 8 and the 13 because those also deal with money. How many children's tickets and adult tickets were sold? So let's go ahead and say children's tickets are X and adults tickets are Y. That means X plus Y gives us our total. And 8X is the total money we got from children's tickets, and 13Y is the total amount of money you got from adult tickets. And again, we can use substitution, elimination, try and graph them. But let's go ahead and use, this is a good one for substitution. So I go ahead and switch this around. Let's say y equals 330 minus x, right? Subtract x from that side. So I'm going to plug that in. So I have 8x plus 13 times, now I'm substituting it in that y, equals my 3,125. Let's go ahead and simplify this. When you grab a calculator, you can. I have my little cheat sheet. So 13 times 330 is 4,290 minus, just distributing that in, 13x. Let's combine like terms over here. We have negative 5x equals our total cost, our total revenue. Let's go ahead and subtract 4,290, and you get negative 5x equals negative 1165. Dividing both sides by negative 5, you get 233. Remember, that was the kids' tickets. So I go ahead and put kids right there, or the children's tickets. And then the adults, we can plug that into our substitution equation up here. Is 330 minus 233, which is 97 adults tickets. Awesome, well done. All right, number 4, we're going to graph two systems of inequalities. So this is a little bit like that problem from chapter 3 in the last video. We have 2 of them, so let's go ahead and write that down before I scroll down. X plus y is greater than 1. 2x minus 8y is less than 5. Okay, and you can use, you can use slope-intercept form, you can use pick-plot plot. I'm going to go ahead and just find the intercepts. X equals 0, so that means y equals 1 for this one. Just pretending it's like an equation. When y equals 0, x also equals 1. So I have 1 and 0. Okay, let's go ahead and do the same thing with the other equation, and we'll look at what the graphs look like. So we're going to have 2x minus 8y is less than 5. So x is 0. I just kind of ignore this first part. Divide by negative 8, and y is 5 over negative 8. Okay, or negative 5/8. And if y was 0, I'd ignore the second part, divide by 2. That would give me 5 halves, or 2.5. So my two equations are, not equations, my 2 points are 0, negative 5/8, and 0, 5 halves. Oops, I wrote that backwards. 5 halves is 0. Alright, let's go ahead and graph these. Both of them have just a less than or greater than sign, and so we're going to have a dashed line. Let's start with 1, 0, and 0, 1. And a dashed line here. You see dashes there. Okay, and then the other one is going to have 5/2, 0, which is 2.5. So it's going to be a little bit farther down, and -5/8. So about there. And a dashed line again. Alright, now let's talk about where, that's a little messy. Let's talk about where to shade. For a system of inequalities, there's going to be an overlap, and that's where you're going to shade. And so let's look at the first one. X plus y is greater than 1. If I plug in my test point 0, 0, that is not a true statement. 0 is not greater than 1. And so I'm going to shade on the other side for that one. I'm doing it just lightly because I'm going to see where they overlap in a minute. Alright, for the other equation, if I plug in my test point 0, 0, I get 0 minus 0 is less than 5, which is true. So I'm going to shade on the side of 0, 0 for this one. So it's going to be above the line there. So where they overlap is going to be kind of like a triangle or a corner of a square right here. It's going to be that spot. So that's where you shade the darkest, where they overlap, and that's the solution. Now, if this question asks for the vertex, we'd need to find the point right there where the two lines intersect, and you can use a system of equations for that. Just treat it like there's an equal sign and solve for x and y. But that's all they asked for on number 4, is just to graph it. So there you go. And that's our chapter 4 video solutions.